Well, hello there! I hope that you're feeling amazing today and also that you're ready to finalize our discussion about operators. It's been a very long journey about operators in Rust, so I feel like we need to conclude this story, and that's exactly what we will do in this lesson. So basically, we are going to separate the discussion we are going to have today into three categories. The first category is going to be dedicated to advanced assignment operators. So these operators are going to allow us to apply some operation and save the value inside of one of those variables. Also, we will talk about comparison operators, and these ones are basically the ones you're going to use almost every day of your coding life, so you should definitely pay a lot of attention to them. And finally, we have bitwise operators, which are going to allow us to shift bits in our variables. So, what are we waiting for here? Let's jump right into some assignment operator action. Okay, we have a ton of stuff to cover today, and waiting isn't going to help us in any way possible. So let's get right into some examples, because I feel like that's the best way to actually understand each of the operators we are going to talk about today. So the first thing that we need to do is to actually create a couple of variables that we are going to be working with. And as you can see in our presentation, I've added a couple of variables and assigned some values to them. As you can see, we have a mutable variable x and a value 10 assigned to it, and also a variable y and value 20 assigned to it. So that's basically the stuff we are going to be working with here. Now imagine the following scenario. We want to assign a value to the variable x, and that value that we want to assign to it is supposed to be equal to sum of values that are stored inside of x and y variables. So in this case, it's going to be 10 plus 20, so basically 30. And to achieve this, we have two options. The first one is the one that you basically already know by this point, I hope. And the second one is going to be one of these assignment operators I'm talking about. So of course, we are going to start things off with a more traditional way to represent this statement, and that is the following one. We have x that is equal to x plus y. And that's it. We will get 30 as a result. But as I already mentioned, we have an alternative approach here to make this statement a bit simpler. And to do that, we can use x plus equals y. And of course, by using this notation, we will again get number 30 as a result assigned to our variable x, which is exactly what we wanted to achieve, right? Please do not get me wrong. Any of these two approaches is completely fine. There is nothing wrong with using the longer approach. I just want to share all the options that you have on your disposal. So if you feel more comfortable with using the traditional way to write down this notation, then please go ahead and do it like that, because this is just a subjective preference and nothing more than that. There is nothing wrong with using either of these approaches. Have that in mind. Of course, these exact same rules apply to the minus operator. So we are going to be using same variables, so same values. Just instead of the plus operator, we are going to use minus operator. So in this scenario, we will get x is equal to x minus y, and we will get minus 10 as a result, because 10 minus 20 is minus 10. And also, the shorter notation is going to be x minus equals y. And again, we're going to get minus 10 as a result, because everything is exactly the same as in the previous scenario, with the slight difference in the fact that we are going to be working with subtraction instead of addition. And while we're here, we're going to cover multiplication, because it's basically the same story. We have the first scenario where we're going to say x is equal to x times y, and we will get 200 as a result, because 10 times 20 is 200. And also we can use notation x times equals y. And we will again get 200 as well, because everything is exactly equivalent. So basically that's it. Now for division, we are going to introduce new values for our variables, just to make results more meaningful and enable them to show you more value from them. So we are going to assign number 35 to the variable x, and we are going to assign 10 to the variable y. And now let's jump right into our example. So our first notation is going to be x is equal to x divided by y. And as a result, we will get 3, because if you remember, division in Rust with integer values is never going to give you any remainder of division. For that, we are going to be using modulus operator, but we are not using it, we are working with division, so just have in mind that we will get 3 instead of 3.5 as a result. And we also have our shorthand representation, and it's going to be x equals y. And we are going to get 3 as a result again, because everything is working exactly the same. And as you probably already know, our last operator is going to be dedicated to modulus. So we're going to be using the same numbers, so 35 and 10, and we are going to use them in the two representations that we have at our disposal. So the first one is going to be x is equal to x modulus y. And for this we will get the result 5, because 5 is the remainder when we divide 35 by 10. And our second shorthand notation is going to be x modulus equals y. And we get 5 again. Nothing more, nothing less. Very simple story, everything works exactly the same for each operator here. So now we managed to cover all the assignment operators, and you have two options for each scenario. So basically, you just double the options to assign values to your variables. And now, ladies and gentlemen, we need to address probably the most important and most significant aspect of this lesson. We need to talk about comparison operators, because as I already mentioned, you're going to use these operators so much in real life that I want you to really master them and to really be able to get the most out of them. So let's jump right into it. So the first question arises, why am I talking about them so much and I'm trying to put their value to the pedestal of some kind? Well, that is because we are really going to be using them in too many places in order for us to be able to just skip them. We need to pay a lot of attention because we are going to be using these operators to compare values all the time. And that is why I want you to really master this. But do not worry, it's not going to complicate it. It's very intuitive, and you're probably already familiar with all the concepts that we are going to cover from your math classes. So I think it's time to start talking about our examples, and to do that we need to cover variables that we will have at our disposal before we do that. So we are going to be using 3 variables instead of 2. So the first 2 variables are basically going to be very similar to the ones that we were using in previous examples. So in this case we'll have x equal to 5 and y equal to 10, and also we will have a mutable variable called z, and it's going to be of type boolean. And now we're ready to get started. So the first operator at our to-do list is going to be greater than operator. And we are going to be assigning the result of these operations to our z variable, because we're going to get a boolean results for our comparison operations. Let's get started with the greater than operator. So you probably already know how to represent it and which character to use for it. Of course, it's greater than. So when we write our expression down, we will get something like z is equal to x greater than y. And how I think is the easiest way to approach this is basically read it as a question. Just read it as, is x greater than y? And if the answer is true, we are going to have true written in our z variable. And in this case, 5 is not greater than 10, so we will get false. It's as simple as that. Not too much stuff going on here, it's fairly straightforward, so I feel you will not have too difficult time to understand this. So we can jump right to our second example, and here we're going to talk about less than operator. So again, the character to represent this is going to be less than, and we are going to write it in the notation z is equal to x less than y. Again, let's try to read it as a question. So we're going to read it as, is x less than y? And the answer is yes, because 5 is less than 10, so we will have true assigned to our variable z. And we're done here! So our third example is probably going to look very familiar to you because we already covered it, so we are going to be quick here. We have equals operator. I just wanted to add it here so we would have a whole story covered at the same place. So we have two equal signs which represent equals operator. So this operator is going to give us true as a result every time that we have two values that are basically the same. So in our case, 5 is not equal to 10, so we will get false as a result assigned to our variable z. Now, my friend, it's time to extend this discussion by introducing a greater than or equals to operator. It's basically the same story as for the case for greater than operator. You will just get true if the values are equal. So in the previous scenario, you would get true only if one variable was greater than the second variable, but in this case you will get true as a result whether it's greater than or equal to. So basically if the first variable is greater than the second one, or if it is equal to the second one. So we have our same values stored in our x and y variables, and we have greater than or equals to operator, so we can ask the question and we'll say z is equal to x greater than or equal to y. So is x greater than or equal to y? The answer is no, because 5 is less than 10. And we're going to store false in our variable, so we can jump right to our second example here. So less than or equal to operator, and the story here is again going to be very similar but a bit different. So our expression is going to look like z is equal to x less than or equal to y, and when we read it as a question, is x less than or equal to y? And the answer is yes, because it is just less than y, so we will get true as a result here. And our final operator is going to be not equal to, and you're going to represent it with exclamation mark and equals sign. So instead of two equals, you have exclamation and equals. This is going to be written down as z is equal to x not equal to y. So we are going to read it as a question. Is x not equal to y? And the answer is yes, because 5 is not equal to 10, which makes sense, right? So we will get true as a result here. Whew. That was a lot of talking about operators. We compared basically everything out there. So right now I can only recommend you to take some time and play around with some examples to truly master these concepts and really remember all of these operators that you have at your disposal. Because practice makes it perfect, right? And right now we have our third and final category to cover, and this one is dedicated to shifting operators. So I'm not going to be able to spend too much time here because these operators are a bit more complex and would require an entire video just to cover them, because we would need to work with binary representation of numbers, and to explain everything in depth would be too complex to put it here, or this video would last for ages. So we're not going to do that, but that does not prevent me from explaining how it works. Because after all, you need to have something to investigate on your own, right? So first, let's discuss who is going to need this the most. So if you're going to be working as a web developer, Rust web developer, you probably are not going to need this functionality all that often. But on the other hand, if you're going to be working as embedded developer, you're definitely going to need to master this concept really well and understand it completely, because in embedded systems, shifting bits is a very important and often used concept. So I just wanted to let you know about this and just to prepare you, so to say, about the use cases of these operators. So we basically have two options here. We have shift left and shift right operations. So basically how this works is you're going to use the binary representation of your number and then just shift all the bits that you have for that number one place to the left or one place to the right, whether you're using shift left or shift right operation. So how to represent these operations? For the shift left, you're going to be using 2 less than characters, and for the shift right, you're going to be using 2 greater than characters. So this is basically it. I do not want to waste too much of your time. You can investigate on your own if you're interested in it, but I just wanted to let you know about this and that you should have it in mind if you ever need it. So, we basically managed to get to the end of this video. I congratulate you for sticking all the way till the end of this lesson. It's been a lengthy one and it's been a wordy one. I've been talking for quite a long time here, so I would like to thank you for sticking all the way till the end with me. And if you did, I would like to kindly ask you to please consider subscribing to this channel and liking this video, because it would help both me and the channel to grow and spread the value to as many people as possible. And for this, I thank you in advance. And in our next lesson, we are going to be talking about another computer science topic. We will be talking about integer overflows. I know that we already mentioned this a couple of times through our videos, and the moment has finally arrived for us to unveil what overflows are and how to handle them properly. So if that sounds interesting to you, I would like to invite you to join me on this upcoming video. So there is only one thing left. I wish you an amazing day and goodbye.